Alright, today we're going to go over section 1 in chapter 5. A figure formed by 3 segments joining 3 non-collinear points is a triangle. Points where the segment meets are the vertex, and the plural of that is vertices. Now, the segments are the sides. We have this triangle ABC on the right side, and we have the vertices A, B, and C, and the sides are AB, BC, and CA, and the angles are ABC, same as the vertex, as this is just a singular figure. Now we have 3 types of triangles. We can classify them by sides and by angles. For the sides, we have scaling, which is the no sides are the same. We have the isosceles, which is at least 2 sides are the same, and then we have the equilateral, which is all sides are equal. We have scaling triangle, which is no congruent sides, that is just shown in this triangle right here. We have the isosceles with at least 2 congruent sides, which is shown by these 2 little tick marks. And then we have the equilateral triangle that has these 3 tick marks of 2 each with 3 congruent sides. Now I want you to realize the isosceles triangle and the equilateral triangle both have tick marks, but because they're not equal to each other, one has 1 and then the other one has 2. Now, to classify them by angles, we have the acute, obtuse, right, and equiangular. So the acute angle, as all angles are less than 90 degrees. Then we have the obtuse angle, which is one angle is greater than 90. Then we have the right angle, which is one angle is equal to 90 degrees. And then we have the equiangular, which means that all angles are equal. Now for an equiangular triangle, all angles are equal, and they're always going to equal 60 degrees, because that is the only way we can break up 180 degrees into 3 even parts. Just as a reminder, the addition of a triangle internal angles are all 180 degrees. For an acute triangle, all of the angles are acute, so less than 90. For a right angle, there is this mark right here to know that there is a 90-degree angle, so a right triangle. We have the obtuse, which is greater than 90, and the equilateral, which are all the same, again shown by these 3 lines, which is the 3 congruent angles. Please note that 89.9 is still acute and 90.1 is still obtuse, and it will have no mark for the 90 degree. Now I want you guys to notice that is a triangle with a protractor. You have a line right here, a line right here. This is going to be 20 as we start on the bottom and move our way up. This one we start at the bottom and move over this way. And this one we're going to go the opposite way as we're looking for that interior angle. So it's going to be 90 plus 20. It's going to be 110. And for the last one, we set it up right here. And it's going to be an angle of 50. As we're going from the top right here to the other line. The sum of the measures of the interior angles of a triangle is 180 degrees. I had mentioned that before. So we can set that measure of angle 1 plus measure of angle 2 plus measure of angle 3 are all equal to 180 degrees. Now, they want us to explain the acute angles of a right triangle are complementary. Why? So we have this triangle, let's get an example, and that is 90 degrees. Now, since the addition of, let's say, A, B, C is equal to 180, because we just learned that, we can say that C is 90 because it's given to us with that square. I'm just going to substitute it in. And then in order to subtract that 90 to solve for A and B, we can say that the addition of those 2 acute angles, in this case angle A and angle B, are equal to 90 degrees. That is the explanation as to why they are complementary. The measure of an exterior angle of a triangle equals the sum of the measure of the 2 remote, which is non-adjacent interior angles. What does that mean? That means that this angle 1 outside, so this one right here, is equal to the addition of angle B plus angle A. Now that is, we're gonna go over some examples. Just as a reminder, interior angles are inside of the triangle. These are interior and these are exterior, as they are outside of the triangle. Now, I'm going to butcher this word, and I'm so sorry. The corollary to a theorem is a statement that can be proven easily using the theorem, and the corollary to the triangle sum theorem is the acute angles of a right triangle are complementary. Now, we prove this by doing the explanation in the slide with the gorilla. That is an explanation as to why they are complementary. So we actually did use the theorem, the corollary to a theorem, which is a statement that we were able to prove. So we have been proving them as we move along. So we have been using corollary. Now, for this example, we gotta state whether the triangle with two angles having the given measure is acute, right, or obtuse. Now I'm gonna go ahead and work them out one at a time. In order to do that, we gotta do A, we gotta do 55 plus 43 is going to be 98. And I'm going to do 180 minus 98, and that is going to be 82. So since we have 55, 43, and 82, they're all less than 90, so this is an acute angle. Now for B, I'm going to go ahead and erase this in order to have space. We have 47 plus 43, that is going to be 90. So if we do 180 minus 90, it's still going to be just 90. Therefore, this is a right triangle. Now for C, we have 80 plus 75. That is going to give us 155. And then we're going to do 180 minus 155. And that is going to give us 25. So since they're all less than 90, we can say that this is an acute angle. Acute triangle, sorry. All right, let's erase this and work on D. D is 33 plus 33, so that is going to give us 66. Then we do 180 minus 66, and that is going to give us 114. Now, since one of these angles, it is bigger than 90, this is an obtuse angle, an obtuse triangle as well. Now, for E, we have 24 plus 66. It's going to give us 90, and then we do 180 minus 90 is going to give us 90. Therefore, that this is also a right triangle. Now, they're asking us in this slide to find angle A, so I'm going to highlight them for all of them. So those are the three angles they want us to find. Now, for the first one, we realize we don't have enough information in this triangle per se in order to solve for it. So we have to find this angle first, as those are verticals. We do that by solving for the left triangle first, which is going to be 80 plus 50 is going to give us 130. I'm going to subtract 180 minus 130, and that is going to give us 50. So this angle right here, it is 50. Therefore, this one is 50 as well, as those are vertical angles. Then I'm going to go ahead and add 50 plus 50. It's going to give me 100. And then I do 180 minus 100, and I get 80 as my angle A. Now, those are the steps for basically all of these problems. Let's go ahead and solve for this A next. So in order to do that, I want you guys to notice that you have this red line. That means those two angles are congruent. So I'm going to go ahead and solve for this one first, as I don't have enough information in the other triangle. So I can say 60 plus 40 is just 100, and then we're going to do 180 minus 100, and it's just going to be 80. So we know that this angle is 80. Therefore, this angle is also 80, as they are congruent by that line. So we're going to do 80 plus this 40 right here, and we're going to get 120. Then we're going to do 180 minus 120, and we're going to find that our angle A is 60 degrees. So we're able to find it by using the same steps every single time. I'm going to go ahead and erase to have a little space to solve for the last A. Now for the last A, also, these two are congruent. That is super important, as the triangle with the A does not have enough information to solve for it the first time around. So I'm going to do 110 plus 30, and that is going to give me 140. Then I do 180 minus 140, and that is going to give me 40 degrees. Therefore, this green angle is now 40. Oh, we found that it was 40. Since they're congruent, this one is also 40. So I can go ahead and do 40 plus 30 is going to give me 70. And I can do 180 minus 70, and I am going to get that angle A is 110 degrees. Okay, so for this one, they want us to find again the measure of angle A, and we're going to use the theorem that the addition of 80 plus angle A equals 120. So I'm going to go ahead and write 80 plus angle A equals 120. So I'm going to go ahead and subtract both 80s on both sides, and I'm going to get that angle A is 40 degrees. Now, for the second problem, they're telling us actually that G is 100 degrees. So I'm going to put that in there. Angle FEH, so this one right here, is 3 times angle F, and they're telling us to find angle F. So this is angle F. We can say that 100 plus angle F is equal to 3 angles F. I'm going to go ahead and subtract angle F from both sides so they're all together. And I'm going to write 100 is equal to 2F. I'm going to divide both sides by 2, and I get that the measure of angle F is 50. Here they want us to find J, K, M, and we do that by setting up 70 plus x is equal to 2x minus 5. Go ahead and subtract both sides by x, and we're going to get 70 equals x minus 5. I'm going to go ahead and add the 5 on both sides, and that will give me 75 is equal to x. Now, x is not the final answer. We're going to have to plug it into here in order to solve for it. So 75, 2 times 75 minus 5, 75 times 2 is going to give me 150, and we're going to subtract 5, and that's going to give me 145, and that is the measure of that angle. Now you could have also found it by doing 75 right here plus 70. I'm going to do it right on the side. 75 plus 70, it's going to give us 145, which is true, as we said that the addition of these two angles equals 2x minus 5 because of the theorem. So either way, it should have been fine. Lastly, they want us to find the measure of each acute angle. So we can write 2x plus x minus 6 is equal to 90. The reason I'm doing it equal to 90 is the theorem that we had spoke about earlier, that if one of the angles of a triangle is a right angle, then we can say the other two are complementary. So that's why I went ahead and wrote it like this. I'm going to combine the x's is 3x minus 6 is equal to 90. I'm going to go ahead and add the 6 on both sides, and it's going to give me that 3x is equal to 96. Divide both sides by 3, and I get that x is equal to 32. Now 32 is not the final answer. We got to actually find the angles. To find this angle, we're going to do 32 times 2, which is going to give me that this angle is 64 degrees. And then we're going to do for this angle right here, 32 minus 6, which is going to tell us that this angle is equal to 26 degrees. We know this one is 90 as it is given to us with that square. And lastly, this is more for your own personal reflection. What part of the lecture that made most sense to you was what, and what part was most confusing to you. That way you guys can ask questions in class. And please remember, you guys do have homework today. It's on big ideas, and please remember to turn it in. Have a good day, guys.